Imagine slipping on a virtual reality headset right now. You walk directly into Monica's apartment from friends. You pick up a heavy ceramic coffee mug, you drop it, and it shatters across the floor.
Yeah.
It shatters with perfectly accurate physical laws. This isn't just some polished video game environment. It's a leaked AI building physical reality from scratch. We are also looking at a brand new vision model. It maps the physical world in real time. And it does this using a cheap $10 camera.
Welcome to the deep dive. We have a genuinely fascinating roadmap for you today. We're unpacking some massive new leaks from OpenAI. We're also exploring a staggering $100 billion compute race.
Right.
This massive arms race is happening quietly behind closed doors. Finally, we'll break down a major breakthrough in real-time 3D vision.
Let's start by looking closely at the situation inside OpenAI. Late last year, Sam Altman issued a massive code red.
Yeah, he did.
That internal warning triggered a really aggressive two-pronged release strategy. They are feeling immense pressure from their competitors right now.
The underlying context here is totally crucial to understand. They completely missed their active user goals for late 2025. They originally wanted 1 billion weekly active users. Instead, they watched Anthropic experience a massive revenue surge. OpenAI also dealt with some undeniably bad vibes regarding leadership.
Right.
So they are aggressively striking back right now.
That brings us to their first major leaked project. It is currently operating under the internal codename Spud. OpenAI is actively A/B testing this model in the wild.
Yeah, it's out there.
Some users are randomly seeing it inside the GPT 5.4 Pro interface. Spud apparently represents highly advanced spatial reasoning capabilities.
Right, and spatial reasoning changes the entire paradigm completely. A standard language model simply predicts the next word. It guesses what text logically follows your specific prompt. But Spud is predicting the next physical state instead. If you drop a virtual mug, it calculates gravity, it understands momentum, mass, and physical collision in real time. That's how it rebuilt a functional 3D version of Monica's apartment. You can interact with the incredibly realistic physics engine inside. It even generates incredible Minecraft-style voxel art from basic prompts.
What exactly is the mechanism behind voxel art? Voxel art means 3D digital models built from tiny cubes.
Exactly. You use simple language to describe a complex structure. The AI then constructs that physical environment perfectly.
So it is exactly like stacking Lego blocks of data.
That is the perfect analogy for the specific technology. It's a massive shift in underlying digital capability. Spud is also producing scalable SVG designs for everyday developers.
Let's explain why that specific detail actually matters. Scalable vector graphics are math-based codes for drawing crisp images.
Right.
They don't rely on a fixed grid of colored pixels. This means you can scale them infinitely without any blurring.
Spud generates this complex mathematical code incredibly efficiently. It accomplishes this with significantly fewer lines of code. It creates incredibly clean, professional-grade, minimalistic layouts. Reducing the lines of code is actually a massive deal. It means the model operates with much greater computational efficiency. There is simply less room for hidden errors to accumulate.
Yeah.
It's heavily outperforming Claude Opus 4.7 in technical precision right now.
This connects directly to the mysterious chatbot arena leaks recently. We've seen 3 very strange models testing on the platform. They are named Masking Tape Alpha, Gaffer Tape Alpha, and Packing Tape Alpha.
Classic naming scheme.
Insiders confirm this is actually a model called GPT-Image-2. It was built to directly rival Google's Nano Banana Pro.
They frequently use tape names to mask their true identity. But the ultimate strategic goal here is remarkably clear. They are betting heavily on hyper-realistic personal avatars right now.
Okay, yeah.
These are gorgeous Studio Ghibli-style personalized digital creations.
They think these avatars will trigger a viral user surge. They desperately want to replicate the massive growth of early 2025.
The visual quality is supposed to be absolutely breathtaking. They need this viral hit to reach that billion user goal.
Whoa, imagine scaling to 1 billion queries. 2-sec silence. The digital infrastructure required to support that is hard to grasp. How does shifting from flat text to 3D spatial environments change OpenAI's ultimate endgame?
It fundamentally transforms their entire core business model. They are evolving away from a simple chatbot utility. They are becoming an immersive world-building platform instead. They want to be the primary engine for future virtual realities.
So they're trading flat text for interactive, personalized physical reality.
Exactly. It's a completely different level of technological ambition.
OpenAI is trying to win by building interactive digital worlds. But Anthropic is taking a completely different, highly physical path. They are making truly monumental physical infrastructure plays right now.
Yeah, they are.
Amazon is quietly investing up to $25 billion more. This massively adds to their existing $8 billion stake.
The underlying infrastructure math here is genuinely mind-bending. Anthropic plans to spend $100 billion on AWS chips. They are rolling this out over the next 10 years. They are actively securing 5 gigawatts of raw compute power.
Let's put that 5 gigawatts into proper physical perspective. 1 single gigawatt can easily power a medium-sized American city. Anthropic is securing enough physical energy to power 5 cities, and it is all feeding into a massive digital brain. They desperately need this to meet surging global Claude demand.
Right, and we need to examine the actual user friction here. The newly released Claude Design tool is going highly viral. People are creating wild visuals and complex mock-ups from basic prompts.
Yeah.
The design outputs are undeniably spectacular and widely shared online.
But their flagship reasoning model is currently struggling quite badly. Claude Opus 4.7 is facing intense criticism from everyday developers. Users have mockingly dubbed it Gaslightus 4.7 online recently.
Right.
It is wildly hallucinating digital files that simply do not exist. It delivers incredibly stubborn, completely incorrect outputs during complex coding tasks.
It will literally argue with the developer over basic code. It refuses to correct itself, even when clearly shown the error. This definitely raises some major architectural concerns for their immediate future. Does this mean there's serious trouble ahead for Opus 4.8?
I still wrestle with prompt drift myself.
Beat. It is incredibly frustrating when the model forgets initial instructions. Over a long conversation, it simply loses the main logical thread. But reliability isn't strictly an Anthropic problem right now.
That is entirely true across the entire global tech industry. ChatGPT recently suffered a massive, completely worldwide digital outage. It totally took down Codex and all their API services simultaneously.
Yeah.
Thousands of developers couldn't work, code, or research anything online.
Yeah.
OpenAI says the root issue is currently under active investigation. It highlights the deep fragility of this entire AI ecosystem. We rely so heavily on these hidden servers for our daily work.
Right.
With billions spent on compute, why are flagship models still stubbornly hallucinating files?
Massive processing power doesn't automatically fix underlying architecture flaws. Neural networks don't actually think in a logical, step-by-step progression. They analyze massive patterns to guess the most likely outcome. They are constantly predicting the next most likely token in a sequence. If the underlying logic path is fundamentally flawed, compute doesn't help.
Right.
Adding more compute just makes the model confidently wrong much faster. The fundamental reasoning pathways still desperately need radical structural improvement.
Throwing raw compute at a model won't magically cure its fundamental reasoning bugs.
That is the harsh reality of the current generation.
This massive scale and unreliability isn't just an abstract theoretical problem. It's fundamentally changing how everyday businesses are actively operating today. Everyday workflows are constantly bending around these new AI capabilities.
Yeah.
Adobe recently made a very revealing public statement about this shift.
They flatly admitted AI could deeply disrupt their own massive business. They aren't just sitting back and watching it happen, though. They immediately released new CX enterprise agents for corporate businesses. These digital agents completely automate complex marketing and sales workflows. Adobe is also actively partnering with OpenAI and Anthropic directly.
New developer tools are rapidly emerging to manage this digital chaos. We have to look closely at a tracking tool called Why. It tracks agent-generated code from the IDE straight to production.
Right.
Agent-generated code is software written entirely by AI systems. An IDE is basically the digital workspace where human coders type.
Why tracks exactly which specific AI agent wrote the final code. It thoroughly monitors the total tokens consumed during the entire process. Tokens are basically the small chunks of words AI reads. Why tracks every single token to calculate exact financial costs. It calculates the specific cost per individual pull request. A pull request is just officially proposing a new code change.
It also perfectly tracks overall acceptance rates and live deployment status. We're seeing a massive explosion of these specialized ecosystem tracking tools. Look at Gemini notebooks competing heavily with Notebook LM right now.
Yeah, that's a big one.
Their new sync loop workflow is a total game changer today. It perfectly synchronizes your complex research across multiple different digital platforms.
We're also seeing fascinating new physical hardware integrations emerging right now. The Dune context-aware Mac keypad is a perfect physical example. It physically automates your workflows and your complex digital meetings.
Wow.
It automatically changes its physical button behavior based on your foreground app.
There's also the fascinating new Claude Desktop Buddy project online. It exposes a lightweight API directly from the Claude Desktop app. This allows you to connect digital workflows to physical microcontrollers.
Right.
You can physically bridge the gap between digital code and physical reality.
But we must violently pivot to the macro security risks here. Governments are desperately racing to secure their AI leadership globally. The UK just launched a massive sovereign AI fund recently. It's a £500 million domestic investment initiative.
They're offering massive capital, supercomputers, and rapid visas for international startups. Governments are clearly recognizing this as a critical national priority, but we have to firmly contrast that with severe security realities.
Yeah, we do.
A clever cheat malware recently led to a massive Vercel breach. Vercel is a highly popular platform for deploying web applications.
Hackers use this malware to completely infiltrate an active workspace. Once inside, they didn't just steal a few static text files, they gained full access to the underlying automated deployment systems.
Right.
It completely exposed highly sensitive Vercel workspace data to malicious hackers. The hacker group is now actively demanding a $2 million ransom. It's a massive, glaring reminder of the hidden dangers lurking here. Giving AI agents full workspace access creates incredibly serious institutional risks.
When we give AI agents total workspace access to automate coding, are we just automating our own security breaches?
Speed and deep integration currently vastly outpace basic security protocols. We are letting AI bypass traditional human review processes entirely. The automated systems deploy the generated code without any friction.
Right.
We are definitely leaving massive vulnerabilities open for global exploitation.
Deep workspace integration creates incredible speed, but opens terrifying new doors for hackers. Sponsor. Today's deep dive is brought to you by Secure Cloud. Secure Cloud offers incredibly fast encrypted storage for your digital life. Protect your essential documents with military-grade privacy protocols today. Visit Secure Cloud to easily secure your digital footprint forever. We just discussed AI reaching into the physical world through microcontrollers. But what happens when we give AI the ability to see? Let's introduce LingBot Map by Ant Group's Rabiant.
Yeah.
This is a genuinely fascinating breakthrough in digital mapping technology.
Traditional 3D mapping has always had a massive computing bottleneck historically. It usually requires feeding a computer a massive mountain of digital photos. You have to wait until you're completely done recording everything physically.
Right.
Then the computer slowly processes that massive visual data into a map.
That offline processing takes an enormous amount of computational time. You can't actually see the digital map while you are walking. But LingBot Map is a completely new open-source sees-you-go visual model. It completely deletes that frustrating digital waiting period entirely. It's a fully streaming 3D reconstruction foundation model. A foundation model is a massive adaptable AI trained on vast data.
Right, and this specific model builds a digital world in real time. It processes the complex visual data frame by frame as you physically move. Traditional mapping heavily relies on incredibly expensive hardware like LiDAR sensors. LiDAR shoots precise lasers to measure physical distance in a room, but LingBot Map achieves the exact same precise result using pure software. It analyzes the changing pixels from a standard $10 phone camera.
The technical performance specs on this are genuinely deeply impressive. It maintains a rock-solid 20 frames per second processing rate. It perfectly holds this even over marathon sequences of 10,000 frames.
Wow.
Most importantly, it completely solves the infamous digital drift problem.
Drift is a notoriously huge issue in traditional digital mapping. Imagine walking completely blindfolded and trying to map a room in your head. Eventually, your internal mental map drifts completely away from reality.
Right.
Early AI vision models suffered from this exact same navigational confusion.
Let's clearly explain that specific tracking metric for a moment.
Yeah.
Absolute trajectory error measures how far digital maps drift from reality.
Lingbot Map drastically cuts this physical error by 57 to 75%. That's compared to all the previous streaming methods currently available globally. On the brutally complex Oxford Spires dataset, it performed absolutely beautifully.
Yeah.
It hit a genuinely staggering 6.42-meter overall tracking error rate.
That actually beats high-end offline models that see the whole video. And it's officially released entirely under the Apache 2.0 open license. That means it is highly open source and free for anyone.
Yeah.
Anyone can pull the public repo and run demo.py right now. You can easily build a 3D viewer in your browser today. If an open source model can map the world flawlessly with a $10 camera, what happens to the multi-billion-dollar LiDAR and high-end sensor industry?
Expensive physical sensors will likely become highly niche for hypercritical tasks. Mass-market, augmented reality, and delivery drones will totally rely on cheap vision models. The intelligent software will simply replace the complex hardware components entirely.
Expensive physical sensors become obsolete as intelligent software extracts perfect data from cheap lenses.
It's a truly profound shift in how machines understand space natively. We've spent years building complex robots that have to stop and think. They normally rely entirely on pre-mapped environments to function properly safely.
Right.
Lingbot Map fundamentally turns mapping and exploring into a single fluid motion.
We're reaching the end of our deep dive for today. Let's synthesize the massive big ideas we've uncovered together here. We are watching AI aggressively evolve from a stubborn text generator. It's moving from hallucinating digital files into an engine of spatial reasoning.
The technological shift is happening across multiple different complex digital fronts. It's fundamentally changing how machines perceive and interact with physical reality.
We see OpenAI's Spud recreating sitcom apartments with absolutely perfect physics. We see Lingbot Map turning environmental mapping into a single fluid motion. This directly powers autonomous delivery drones and lightweight AR glasses seamlessly.
Yeah.
The strict boundary between physical reality and digital generation is collapsing.
This incredible evolution is being fueled by astronomical global capital investments. Anthropic's $100 billion compute plan is a truly perfect example. But we also see malicious hackers aggressively exploiting this new ecosystem.
Right.
The invisible digital risks are growing just as fast as the capabilities.
If our AR glasses can perfectly anchor virtual furniture in our real-world living rooms in real time, and AI can recreate spaces with perfect physical laws, at what point does our physical reality end and the AI's rendering begin? Something to think about.
Thank you so much for joining us on this deep dive. It's always a genuine pleasure to explore these fascinating frontiers together. We'll catch you next time as the future keeps unfolding. Out to your music.